Hello and welcome to our class today. Today we'll be learning acids. Now, what is an acid? An acid is any substance which produces hydrogen ion or hydrozonium ion as the only positive ion when dissolved in water. Any substance when dissolved in water produces hydrogen ion or hydrozonium ion as the only positive ion when dissolved in water. When you dissolve tetrazosulfate 6 in water, it's going to give us ionization. It's going to give us hydrogen ion and tetrazosulfate 6 ion. So this, any substance which when you dissolve it in water, it will produce hydrogen ion or hydrozonium ion, is what we refer to as an acid. Now, let's look at the various classes of acid we have. We have two classes of acid. We have what we call the organic acid and we have the inorganic acid. Organic acid, as the name implies, are those acids that are gotten naturally. We get them from nature. While inorganic acid are those acids that are not gotten naturally. They are produced chemically in the laboratory. So let's look at the organic acid here and their sources. We have what we call the ethanoic acid. The ethanoic acid is gotten from vinegar. We have the lactic acid. The lactic acid is gotten from milk. We have the citric acid. The citric acid is gotten from lemon and lime. We have the ascorbic acid. The ascorbic acid is gotten from oranges. We have the amino acid. The amino acid is gotten from proteins. We also have the fatty acid. The fatty acid is gotten from fats and oil. Then in the inorganic acid, the acids that are produced in the lab, we have acids like tetrazosulfate 6 acid, tetraoxosulfate 6 acid. We have acids like trioxonitrate 5, trioxonitrate 5 acid. We also have acids like hydrogen chloride. All these acids, as you can see, they are not naturally obtained. Rather, they are chemically produced. Okay, so let's look at the two main types of acid we have. So let's look at acids according to their ionization types. And now ionization simply means dissociation in water. As in when you dissolve an acid, it dissociates into different ions. Alright, so we have what we call the strong acid. Strong acid ionize completely in water to give you hydrogen ion and anions. They ionize completely in water. Example, you have your hydrogen chloride, you have your tetrazosulfate 6. Now, hydrogen chloride, when it ionizes in water, it gives you hydrogen ion and chlorine. Now, this is the hydrogen ion acid, and this is the anion. Anion means a negatively charged ion. Then, you also have your tetraoxosulfate 6. Tetraoxosulfate 6, when it ionizes in water, it gives you two ions of hydrogen and an anion. Then you also have triosonitrate 5 acid. When it ionizes in water, it gives you hydrogen ion and an anion. So these are strong acids. These three acids are strong acids. Now we look at weak acids. Weak acid, they ionize partially in water to give you hydrogen ion and anions. Examples of weak acid are, you have ethanoic acid, you have triosocarbonate 4 acid, and you have tetraoxophosphate 5 acid. Tetraoxophosphate 5 acid and triosocarbonate 4 acid. So let's look at how they ionize. When ethanoic acid ionizes in water, it will give you hydrogen ion plus this. When triosоphosphate 5 acid ionizes in water, it will give us hydrogen ion and phosphates. This is the end product of it. What is the basicity of an acid? The basicity of an acid is the number of replaceable hydrogen ion present in one molecule of an acid. That is what we refer to as basicity. How many replaceable hydrogen ion are present in this acid? Now let's look at it. When you look at something like tetrazosulfate 6, when it ionizes, it will give 2 hydrogen ion plus the anion. So what is the basicity of tetrazosulfate 6? We say it is dibasic. Dibasic means 2. Let's look at hydrogen chloride. When it ionizes, it gives you what? Hydrogen chloride plus chlorine. So what's the basicity? The basicity is monobasic. Monobasic means that it is 1. Let's look at tetrazophosphate 5 acid. When it ionizes, it gives us what? So we say it is what? Tribasic. Tribasic. Let's look at triazocarbonate 4. Triazocarbonate 4 acid. When it ionizes, it gives us this. So we say it is what? What's the number of replaceable hydrogen here? We say it is what? Dibasic. Let's look at ethanoic acid. Ethanoic acid, when it ionizes, it gives you what? 1 hydrogen and this. So ethanoic acid is what? Monobasic. So you are going to be looking at the number of hydrogen ion present when an acid ionizes. That will definitely give you the what? The basicity. Put down the answer to this question in the comment section. What is the basicity of triazosulfate 6? Triazosulfate 6. What will be the basicity of this acid? Put down your answer in the comment section. Okay, so let's move over to the properties of an acid. Okay, so let's look at the physical properties of an acid. Now, when we talk about physical properties, we mean those things that are limited to the 5 senses. Something that you can see, you can smell, you can feel, you can taste, or you can hear. So that's what we refer to as the physical properties of an acid. Okay, so number 1 is that acid have sour taste. They taste sour. For example, if you taste lime, you discover that it has this sour taste. The same thing with lemon. You discover it has this sour taste. That is how acid tastes. Number 2, they turn blue litmus paper red. All acid do that. 3, they are corrosive. Corrosive means that they can burn. If you take a drop of concentrated tetrazosulfate 6 and put on your skin, man, you are a goner. All right, we look at the chemical properties. Now, the chemical properties, number 1 is that they react with metals to liberate hydrogen gas. All acid react with metals to liberate hydrogen gas. Let's take, for example, this acid, hydrogen chloride, reacting with a metal. The metal, let's say, is reacting with zinc. Is going to give us what? Is going to give us, zinc is going to displace this acid to form zinc chloride plus hydrogen. This is a characteristic of acids. This is a characteristic of acid. They react with metal to liberate hydrogen. Number 2, they form salt when they react with base. We call it neutralization reaction. A reaction where an acid reacts with base to give you only 2 products, which are salt and water only. So an acid here, let's say you have your tetrazosulfate 6 reacting with sodium hydroxide, which is a base, is going to give us sodium tetraozosulfate 6 plus water. So this is the salt form. Then the third one, they react with triazo carbonate 4 to liberate carbon 4 oxide. Example, if you have an acid like hydrogen chloride reacting with potassium triazo carbonate 4, is going to give you, this go with this, is going to give you potassium chloride plus water plus carbon 4 oxide. So this reacts with this, then this one, you have hydrogen and this left, is going to decompose to give you carbon 4 oxide and water, so thereby liberating carbon 4 oxide. Okay, so let's look at how to prepare an acid. How do you prepare an acid? There are basically 3 ways to prepare an acid. The first one is by dissolving an acid anhydride in water. Now, what is an acid anhydride? An acid anhydride are oxides of nonmetals, which when dissolved in water produces acid. Any oxide of nonmetal that when you dissolve it in water is going to give you an acid, we call it what? Acid anhydride. Example, you have sulfur. You know that sulfur is a nonmetal. So the oxide of sulfur, you have sulfur 4 oxide. When you dissolve it in water, it's going to give you what? An acid. It's going to give you this acid. If you have this acid anhydride, this one is going to give you tetraozo sulfate 6. If you dissolve carbon 4 oxide, carbon is a nonmetal, it's oxide. If you dissolve it in water, it's going to give you what? It's going to give you this. How many is it? Carbon. 1 carbon. Oxygen is how many? 3. So it's going to give you triazo carbonate 4 acid. Please take notes. Here you have hydrogen 2, 1 sulfur, 3 oxygen. Triazo sulfate 4. Then here you have 3. You have 1. Here you have 2 hydrogen, 1 sulfur, 3 plus 1, 4. Tetrazo sulfate 6. Then here you have 2 hydrogen, 1 carbon, 3 oxygen. So these are what we refer to as an acid anhydride. But take note, look at this. Carbon 2 oxide reacting with water. If it reacts with water, what is it going to give you? It will give you H2O2. Now, this acid does not exist. Therefore, carbon 2 oxide is not an acid anhydride. Please take note. Acid anhydride are oxides of nonmetals which when dissolved in water produces acid. Carbon 2 oxide is not an acid anhydride. Please take note. Alright, so with this you can produce an acid. Then we look at the number 2, direct combination. Direct combination is simply reacting this and this, bringing them together. That's what we refer to as direct combination. Let's look at this. If you react hydrogen and chlorine in the presence of a catalyst, you will have what? Hydrogen chloride. This is what we refer to as direct combination. Bring this one. Sorry, you're supposed to have a 2 here and another 2 here. Then you can now balance the equation. So reactions like these are what we refer to as direct combination. Then number 3 is using a strong acid to displace a weak acid from each solution. A strong acid like, remember, we have 3 strong acids: tetrazo sulfate 6, triazo nitrate 5, and hydrogen chloride. If you have forgotten, go back, replay, and go back in this video. So something like, say, tetrazo sulfate 6 acid, if you react it with sodium trioxonitrate 5 salts, it's going to give us sodium tetraozo sulfate 6 plus triazonitrate 5. Now, by the formation of this triazonitrate 5, you have been able to get another acid. Now, this is a salt of an acid, but you want to get an acid. So you used a very stronger acid. It was able to displace sodium from this. And then you have your acid, triazonitrate 5 acid at the end of the day. Okay, so let's look at the uses of acid. Now, the uses that we are written down based on, over the years, the questions examiners have asked. Outside these uses, there are so many other uses it is used for. But remember, this is JAMB Chemistry, so we are doing it to suit the examination. So please take notes. There are other uses, but these are the major questions examiners have asked over the years. Now we look at hydrogen chloride. Hydrogen chloride acid is used for pickling. What is pickling? Pickling means to remove rust. You must have seen questions that say which of the following is used for pickling. It is what? Hydrogen chloride. Tetrodosulfacic acid is used as an electrolyte, and it's also used as a what? Drying or dehydrating agent. Then triiodonitrate 5 is used in making fertilizers and explosives. It is used in making fertilizers, explosives like matches. Okay, explosives like matches. Then boric acid is used in making germicides. Germicides like Dettol, anything that kill germs. Then tartaric acid is used in making soft drinks, baking soda, and health salt. Please take note, this tartaric acid is a favorite question by examiners. Ethanoic acid is used as a preservative. We use it in preserving things. Then citric acid is used in making fruit juice. We use it in making fruit juices. Fatty acid is used in making soap. I hope we're enjoying the class. Are we following? Okay, so let's move over to base.